Bismillah ar-Rahman ar-Rahim. The title of the paper is Structural Static Evaluation of Historical Stone Building Case Study Zahd Building in Hebron Old City, prepared by Dr. Ghassan Dweik, Dr. Haytham Ayyad, Engineer Afnan ALkaraki. The idea of the paper is that historical buildings are important in documenting in an entire civilization and era, as that found of many ancient historical and heritage buildings that need a structural evaluation in order to preserve its sustainability, durability, the architectural style, and revive them to be suitable for use. To conduct the evaluation process, it is necessary to damage detecting, determine the mechanical properties, nonlinear analysis based on finite element using ANSYS program. The number of historical buildings in Palestine is about 50,320, while the number of historical buildings in Hebron is about 10,322. The research problem is about the process of the evaluating and modeling historical buildings is difficult for several reasons, which is lack of quality, control during construction, complex geometry, difference in mechanical properties, lack of knowledge about the mechanical properties, inelastic and heterogeneous materials consisting of stone and mortar, modifications, repairs, and other interventions during their life. These repairs were carried out with almost different materials. And this picture shows random additions at different time stage in Hebron. The case study is Zahd building is located in the center of old city of Hebron, near to the Ibrahimi Mosque. The front elevation of building, the building is composed of two main floors rising above the stores with total area of about 550 square meters. The plans of the building, the experimental program, which is non-destructive test, including three parts. First, testing of old stone. Second, testing of old mortar, include compressive and tensile test. And the third, testing of stone and mortar in three ways. Core test, but the samples are failed. Testing the model samples in lab and Schmidt hammer test. This picture shows the source location of historical stone from collapse building in Old City Hebron. And this picture shows the stage of preparing the historical stone to cut into suitable pieces by CNC for experiments and to determine mechanical properties. The result of stone units, which compressive strength of old stone that the value range between 68.8 to 161.6 megapascal. Three types of models were built from stone and mortar with different dimension in scale 1/6. Models were tested at 3 months of age to determine compressive strength, modulus of elasticity, Poisson's ratio using uniaxial Matisse hydraulic press machine. The result of the model sample are as follows. For models with dimension of 30 cm, the average compressive strength is 15.3 megapascal. For models with dimension of 40 cm, the average compressive strength is 12.9. For models with dimension of 20 centimeter, the average compressive strength is 16.4, and the modulus of elasticity is estimated at 60% of FC prime. The average value of Poisson's ratio is about 0.2. The theories that are followed in the finding mechanical properties. Two types of models were built from stone and mortar with same dimension in 1/6 scale, the first type of samples without steel, and the second type of samples with steel 2/5/6, as shown in this figure. Models were tested at 3 months of age to determine flexural strength using control flexural testing machine with 2-point load. The result of a flexural strength that's shown in table and figure. The numerical analysis and modeling divided into 2 main parts. The first is validation of modeling for flexural stone beam models, and the second part is the modeling of the building. The result of validation of modeling shown in the figure and table that indicate good agreement between experimental and numerical answers, as shown in load deflection curve of flexural beams. The materials properties used in modeling of the building that the element type is solid 65, modulus of elasticity is 843 megapascal, Poisson's ratio is 0.2, weight density 22. The failure criteria is Wheelam and Rankine. Ft is 0.81 megapascal, Fc 8.1 megapascal, and the multilinear isotropic of material is determined based on the equation number 3. The loads divide to existing load and additional loads. The existing load includes self-weight and the life load. The additional loads that apply to the wall of existing situation, and the additional loads were calculated from dead load that estimated from slab and wall for 1 floor, 2 floors, and 3 floors. The solution output of the building model of existing situation that bears its own load and is stable. Sigma 1 is compared with Ft, sigma 3 compared with Fc, where sigma 1 is less than Ft, sigma 3 is less than Fc. And when the loads of 1 floor are added, the building is stable and bears, as well as when 2 floors are added. But when adding the 3rd floor, the failed occurred and sigma 1 is more than Ft. In responding to the research objectives, this paper aimed to evaluate the performance and load carrying capability of the building. So, nonlinear analysis was performed using finite element computer code ANSYS. A macrostructure strategy of modeling was used. The building represented by solid 65. The Wheelam-Rankine model was used as the appropriate failure criterion. ANSYS has the ability to perform a nonlinear analysis of old building and gives good results. The main conclusion may be represented by the result of finite element model indicate the good structural state of current building, and the number of floors allowed is 2 floors. Allowable additional loads are estimated 3,440.9 ton. The study results of the experiments can be adopted on the same old materials of stone and mortar. In addition to that, the numerical analysis can be applied in modeling similar historical building materials. Hebron is rich of old stone buildings. The necessity of preserving this heritage is invaluable in order to pass it to the future generation. Thank you.